As we done in the earlier lecture about the distance between 2 points, now we will learn how can a point divide the line segment in a particular ratio, and that derivation or that formula which gives the coordinate of that point is called section formula. So we will derive section formula for a line segment joining 2 points in R cube, that is three-dimensional space. For this, let R1 with component x1, y1 and z1 and R2 with component x2, y2, z2 be the position vectors of 2 points A and B in the space respectively. First, point P belongs to AB line segment where P is not equal to A and P is not equal to B, and as the points ABP are on the same line, then the direction of AP and PB are same or opposite. Such that P divides the line segment AB. As AP and PB have same or different directions, then by definition of direction of two vectors, it will be AP vector k times PB vector, where k is not equal to 0. Therefore, length of, that is if we take magnitude on both sides, it becomes magnitude k, magnitude PB vector. That gives AB. Magnitude AB can be written as simple AB, that denotes the length, is equal to k times PB. That gives AP over PB is equal to k. Give its name as number 1. Now let the position vector of point PB x, y, z, that is vector r. So let P divide line segment AB from the side A in the ratio lambda. That is, if we take a line segment that is AB and there is a point P which divides in the form from the side A, that is AP over PB, in the ratio lambda. Now the first case, if lambda is greater than 0 and APB is a line, that is P is lying between A and B somewhere, then AP over PB is equal to lambda. As P divides AB in the ratio lambda. Then we say P divides AB internally as shown in the figure in the ratio lambda from the side A. Therefore, AP over PB is equal to lambda. That is positive, we can say, if we compare, that is equal to modulus K. As AP and PB have same direction, then K is greater than 0. That is, modulus K is equal to K. Therefore, AP over PB is equal to lambda is equal to K. That is, if we take from number 1, lambda is equal to K, that means AP over PB is equal to lambda, that is equal to K. That means lambda is equal to K. Thus, from the starting equation, that was AP is equal to K times PB, becomes vector AP over vector PB is equal to lambda. So lambda divides AP is to PB in the ratio lambda internally. Now second case, if lambda less than 0 and we have the form PAB and AP over PB is equal to minus lambda, then we say that P divides AB line segment externally from the side A in the ratio lambda. That is, if we draw the diagram, it will be A, P, B. That is AP and PB. That is, from the diagram it is clear that as AP and PB have different direction, Therefore, k is less than 0. That implies modulus k is equal to minus k. That is, AP over PB is equal to minus k. But we have AP over PB is equal to minus lambda. Hence, in this case also, lambda is equal to k. Therefore, AP vector k times PB vector becomes AP lambda times PB, as P divides AB in the ratio lambda from the side A externally. So in each case, we have AP is equal to lambda times PB vector. Therefore, AP position vector of AP will be R minus R1 lambda times R2 minus vector R. That is, if we take same factor of R here, it becomes 1 plus lambda R is equal to lambda times R2 vector plus R1 vector. So we get vector R is equal to lambda times R2 plus R1 vector over 1 plus lambda, as lambda is not equal to minus 1. So if we write all these in the form of component, we will get, that is in form of components, we will get x, y, z, that is a component of vector R, lambda times x2, y2, z2 plus x1, y1, z1 over 1 plus lambda. So on adding and comparing both sides, we get x component is equal to lambda times x2 plus x1 over 1 plus lambda. Y component is lambda times y2 plus y1 over 1 plus lambda, and z component is equal to lambda times z2 plus z1 over lambda plus 1. So these are the component of vector P. Therefore, point P divides the line segment AB in the ratio lambda from the side A with component x, y, z. If we take lambda is equal to m over n, then the above formula that gives the coordinate of P becomes, that is vector R is equal to component x, y, z is equal to become m over n x2 plus x1 over m over n plus 1, comma m over n y2 plus y1 over m over n plus 1, comma m over n z2 plus z1 over m over n plus 1. That gives m times x2 plus n times x1 over m plus n. That is m times y2 plus n times y1 over m plus n, comma m over n z2 plus n times z1 over m plus n. So these are the formula in the form of m over n ratio. Here we have to write m. So this is a section formula in the form of m is to n ratio. Similarly, if P divides from side B with position vector x2, y2, z2, then coordinate of or components of P becomes, that is, interchange the position of x1, x2, y1, y2, z1, z2. That is, vector r is equal to x, y, z is equal to lambda times x1 plus x2 over lambda plus 1, lambda times y1 plus y2 over lambda plus 1, lambda times z1 plus z2 over lambda plus 1. So these are the components when P divides the line segment AB from the side B in the ratio lambda, and if it divides in the ratio m is to n, then component of P becomes, when it divides the line segment from the side B, is mx1 plus nx2 over m plus n, that is the x component, my1 plus ny2 over m plus n, that is the y component, and mz1 plus nz2 over m plus n, that is the z component. So it was all about the section formula which gives when P divides from the side A or side B internally or externally, then what are the components of point P.